everyone. I'm Julie Bauer with the Saint John Naturalists Club. So really quick, our club is all about studying and enjoying nature, participating in various animal conservation projects and more. If you'd like to learn more or get involved with our projects, we're on Facebook, Twitter, and Instagram at Nature Saint John. So today's talk will feature Gina Lonati, a PhD student at the University of New Brunswick, Saint John. Gina will talk about her experiences in marine mammal research, as well as some marine mammal species that you may encounter around Saint John and the Bay of Fundy. In particular, she will discuss the dire situation with critically endangered Northern Atlantic right whales and how researchers are using new approaches and technology to contribute to their conservation. So it is my pleasure to introduce Gina Lonati.
Thank you, Julie, and thank you both to Harbourview High School. Can't see you all, but nice to meet you, and as well as the Saint John Naturalists Club for inviting me. I love talking about this material. It's very near and dear to me, and I love sharing my passion with other people. So excited today to talk about North Atlantic right whales in particular, but also discussing other marine mammals that you might find in your backyards. And so as this video has been playing, I'm hoping you've noticed these are 3 North Atlantic right whales that we actually saw not in the Bay of Fundy, but in the Gulf of St. Lawrence this past summer. There's a focal female here. She actually has a heart-shaped mark on her back. So if you notice that, she's the female. We've got 2 males exhibiting some mating behavior in this group. So a nice, pretty video of right whales to start the presentation. All right, so a little bit about myself. I'm American, I'm from the US, originally New Jersey, and I've traveled up and down the east coast of North America for various internships and jobs in the marine biology field. I moved to Saint John in 2019, so just before the craziness set in, but I've really enjoyed my time here. I started the PhD program at the University of New Brunswick, Saint John in January 2020. So I'm just entering my 3rd year of my PhD degree in the biological sciences department. And so ever since I was a little kid, I was obsessed with the ocean. I loved going to the beach. My family took me to all the local aquariums when we went on vacations. I got to meet a dolphin when I was young. I tried snorkeling and scuba diving. And I'm really excited to say that I turned that into a career. So I've gotten involved with various research projects. I've gotten to help conserve some species, protect and raise awareness about some endangered species. I get to do outreach like this. So again, raising awareness and educating, my peers, older people, younger people, all ages. So gotten involved in some cool experiences along the way. But the constant through my whole life has been this fascination, especially with marine mammals. I just love the way they're adapted for their aquatic lifestyle, how they're mammals like we are, but they dive really deep and they range over these huge distances. And so you can tell that my passion for these animals has not changed between 2000 and 2016. I still get excited every time I see a dolphin. So I'll give you a little background. What is a marine mammal? So these are some examples, not all of them on the screen, but marine mammals, like I said, are mammals. They breathe air. They give birth to live young. They lactate or provide milk for their young, and they all have hair. Now you might go, does a dolphin have hair? And actually when they're born, they have little hairs on the tip of their rostrum or their beak, and they lose those over time. Even manatees here, which are mostly found in Florida, in the Southeast US, they have little sensory hairs as well. Now, marine mammals are distinct from other mammals because they depend on the ocean for most or all of their needs. And most of these marine mammals have thick, insulative fat layers called blubber that prevent them from losing a lot of their heat to the environment, their aquatic environment. What a lot of people don't realize is that marine mammals evolved from terrestrial ancestors. So those ancestors, originated in the water, came on land, and then went back into the ocean. So in the case of sirenians, which include manatees, dugongs, again, some more tropical species, their closest modern day relatives are the elephant. And back in the day, they used to have 4 legs. They walked on land, but became more adapted for their aquatic lifestyle. And now we get the form that we are familiar with today. Same with the cetaceans, or the whales, dolphins, and porpoises. They also had a terrestrial ancestor. Again, this like rat-like creature that walked on all 4s. Those hind limbs receded, the forelimbs became flippers, and they evolved these nice paddle tails. And so their closest modern day relative is the hippopotamus. So I want to introduce you to some of the local marine mammals that you might encounter either on the water or you're going for a walk along the beach. We've got a lot of different species to be familiar with, and you can often recognize them just by standing and looking with the naked eye or through binoculars or a camera. We have 2 main species of local seals, and the best way to observe them is when they haul out at low tide to rest and sunbathe. So there are various locations along Saint John River and the harbor where they'll do this. You can also see them swimming around. But harbor seals are the smaller of the 2 species. They are brown, silver, tan, or gray, about 6 feet long. And that's where a lot of the local sports teams get the Sea Dog nickname, is after the harbor seal. And the gray seal is a bit larger. They're distinct from the harbor seal. The harbor seal has kind of a puppy-like face, whereas the gray seal has this elongated horse-like face, and they're gray or brown in color. And if you ever see a seal, or you're interested in learning more about seals, the Atlantic Coastal Action Program in Saint John conducts a lot of population surveys where they'll go out to these known locations where the seals will haul out at low tide, and they count the seals, and they're always looking for citizens to report to them their seal sightings. So you can go to this website in case you're interested in learning more about helping with that. We also have several dolphins that can be found in the Bay of Fundy near Saint John. These are often observed in groups, which are called pods. So we have the Atlantic white-sided dolphin, which has this kind of yellow streak between its dorsal fin, or the fin on its back, and its tail. And this one can be easily confused with the short-beaked common dolphin, which has a yellow streak between its eye and its dorsal fin. And unless these dolphins are leaping out of the water, which does happen, it's very hard to tell when they're just surfacing. All you'll see is a bit of their head or their blowhole and a dorsal fin coming out of the water. But if you do get a chance to see them leap, it's really fun to watch, and you might be able to identify them. The white-beaked dolphin has no yellow, just this white streak along its back. They're all about a similar size. Now, I want to distinguish the harbor porpoise from dolphins. So they're actually very taxonomically distinct. Harbor porpoises are smaller than dolphins. Their dorsal fin is very triangular, whereas a dolphin has a falcate, or a very curved dorsal fin. They also have a shorter or more blunt snout, whereas the dolphin has this long beak. And if you ever have the chance to look inside a harbor porpoise's mouth, you'll notice their teeth are shaped like shovels or spades rather than the conical pointy teeth of dolphins. But hopefully you never find yourself like inside a harbor porpoise mouth. All right, we also have a bunch of local baleen whales. And the baleen whales, they don't have teeth. Instead, they have these keratinized plates. So keratin, same material as our fingernails and our hair. They're like stiffened bristles in their mouth that act like a spaghetti strainer. So these whales will take a volume of water in their mouth and push it through this strainer of baleen, and it traps all the little plankton, which are their prey. So it's really interesting that some of the largest whales eat some of the tiniest plankton in the ocean. We have 4 main whales that are often seen in the Bay of Fundy. The first is humpback whales. So the one on the left here, they're characterized by these very long white flippers and these kind of bumps on their face and their flippers called tubercles, which might have a dual role in the hydrodynamics for swimming as well as sensing their environment. You also have minky whales, which are small, probably the smallest of these species. They have shorter flippers, but this white streak on their flipper. We also have fin whales, which second to the blue whale, it's the second largest whale in the world. So you might be familiar, the blue whale is the largest at 100 feet long, the fin whale close behind. And they're very sleek and streamlined. And actually, if you ever get to see both sides of a fin whale, the right side of their jaw is white and the left side of their jaw is a darker gray. And it's thought that this has some purpose in like surprising the small fish and plankton that they will catch. So they have very interesting coloration on their heads. And then we have North Atlantic right whales, which are quite distinct shape-wise from the rest of the whales. So North Atlantic right whales are a little more rotund, not as streamlined as these other species. They're darker in color. They have these paddle-like flippers instead of these elongated or pointy flippers. They also don't have a dorsal fin. These other species have very small ones. And what's very unique about North Atlantic right whales is they have callosities, which are these roughened patches of skin on their head. They're cream or white colored. And I'll get more into how those callosities are used to identify individual whales. Now, most of the time you probably won't be seeing a whale from above or underwater. So a lot of the times you're either looking from land or from a boat, and you'll see the whale surface to breathe. And you can actually tell a lot about the species of whale you're observing just from examining the vapor that is exhaled. So when the whales surface, their blowholes are kind of concave and water will sit on top. And when they exhale forcefully, that water gets shot into the air. So it's not like they're spitting any water. It just kind of sits on top of the blowholes. And so a humpback whale has a very tall and bushy blow. A minky whale is smaller and has kind of a short, if at all visible, sometimes it's not even visible, but they're also known to pick their very chin up out of the water when they surface. Fin whales will also pick their chin up, but they have a very tall column-like blow. And then right whales, the way their two blowholes are positioned on their head, when they exhale, the water shoots out in a V shape. So a very distinct blow pattern from right whales. All right, so the rest of the my talk, I'm going to be talking mostly about North Atlantic right whales. Sadly, they're critically endangered. These animals likely can live to be 70 years, but due to a lot of threats, which I'm going to get into, if they make it past 35, they're doing pretty good these days. Females will mature around 7 to 10 years and males a little bit later. Mating behaviors will occur year-round and calves are born in the winter. And North Atlantic right whales have two cousins in other parts of the world. So the North Pacific right whale, again, in the North Pacific. And there's also the Southern right whale, which is around the Southern hemisphere. These different species don't interact, so they're genetically distinct and recognized as 3 separate species. North Atlantic right whales are distributed along the east coast of North America. So they will give birth to their calves in the fall and winter in their southern calving grounds. So that's off of Florida, Georgia, South Carolina. And then they'll migrate upwards, up north to waters off of Massachusetts, as well as the Bay of Fundy and Roseway Basin and kind of the Gulf of Maine, which is where they'll spend their summer and spring feeding on these tiny little rice grain sized plankton, which I'll talk about a little bit as well. And so how do we know how many North Atlantic right whales there are? Like I said, they're critically endangered. And thanks to those callosities, that thickened skin on their head, we can photo identify individuals. So each whale has a unique callosity pattern, and you can just compare just a few of the whales, the mom-calf pairs here. And this allows researchers to track individuals over time and space and study the lineages of these animals, which is pretty cool. So sadly, the right whale got its name because it was considered the right whale to hunt. These whales have a lot of blubber. They come close to shore because of their migratory routes. And so they were easy targets for harvesters to harpoon. And then because they had all this blubber, they would float after death, making it easy for people to pull them on board. So before whaling became very big, their population was already pretty small, so fewer than 2,000 individuals. But then between the late 18th century and early 20th century, they were hunted to becoming nearly extinct. And it was thought that there were fewer than 100 individuals at one point in time, possibly just a couple dozen at its ultimate low. Now, the species has started to recover since there was a moratorium on hunting right whales in 1931. However, it's been slow. As you can see, the numbers, even at their peak in 2010, were still less than 500. Sadly, since 2010, mortalities have significantly increased and reproductive rates have declined. And as of 2020, the best population estimate was 336 individual North Atlantic right whales. So what's happening? Why are the whales not recovering? In the words of one of my colleagues, Dr. Michael Moore, we are today whaling by accident. So the leading threats to right whales are due to human activity. The first one being entanglements in fishing gear. So it's estimated that 86% of the population has been entangled at some point in its life, some individuals 6 or more times. Between 2003 and 2018, it was documented that 22 right whales died from entanglement in fishing gear. Other very big anthropogenic impact on these whales is collisions with ships and other boats. That was estimated to be responsible for 16 mortalities between 2003 and 2018. And then there have been significant declines in the quality and the quantity of their plankton prey. So this photo here shows a copepod, which is the primary prey of these whales, again, about the size of a grain of rice. And due to climate change, so warming waters, changing currents, it's resulted in less prey being available for these whales, which has led to a decline in health, which then exacerbates the effects of collisions with vessels, any injuries, and as well as entanglements. So interestingly, this sudden decline in 2010 coincided with a shift in the distribution of right whales during the summer in their feeding habitats. So this image here on the left shows sightings of right whales between 2000 and 2009. And you can see there were a lot in the Bay of Fundy, a lot in the Roseway Basin off of Nova Scotia. This is Great South Channel. And then in 2010 to 2019, you can see the red circles show where sightings declined, and the green shows where sightings increased. So whales started showing up in the southern Gulf of St. Lawrence, and they've been essentially abandoning the Bay of Fundy over the past decade. In fact, the past 2 years, researchers haven't observed a single right whale in the Bay of Fundy. And so unfortunately, this shift to the southern Gulf of St. Lawrence has been detrimental for right whales because there's a lot of human activity, a lot of shipping traffic, a lot of fishing, and we're still unsure about the quality of the copepods that can be found in the southern Gulf of St. Lawrence. So we're seeing more instances of anthropogenic trauma. This is an entangled whale. You can see it was so badly entangled, its baleen got broken and sticking out of its mouth. We're seeing more mortalities from entanglements and ship strikes, and we're seeing fewer calves born. So what is being done? I mean, we're not just sitting and watching this happen. A lot of people, a very interdisciplinary group, many organizations across borders, the US and Canada, are working together to try to protect the North Atlantic right whale. So I'm going to be talking about 4 main strategies that people are using to help the right whales. We'll talk about research, both of the whales and their prey. I'll talk about rescue operations and interventions, talk about management and some of the things the government is doing to regulate vessel traffic and fishing. And I'll also talk about how we're increasing public awareness through outreach and education. So I'll first focus on the research. So how do scientists study whales? It's very challenging, actually. These whales are fully aquatic, so don't come on land where we can just have a look at them. They hold their breath for long periods of time. They can dive very deeply, so you're never sure when they're going to pop up and where. And they have these huge distributions. So, you know, they might be in the Bay of Fundy one year, but not the next. So they're very hard to find. So researchers will conduct research from 3 different platforms. We can look at whales from land. Now, North Atlantic right whales do come close to shore, so it is possible to look at them through different technologies like binoculars, cameras, and this is called a theodolite. Also, we go in planes and look for them that way. We can cover a much broader range via plane, although you can imagine it's a lot of staring at open water, but sometimes you'll find a little something in the distance and it turns out to be a whale. We also conduct a lot of research from vessels or boats, and that allows us to get a little closer to the animals with permits and collect some detailed information. But of course, we're limited in how far the boat can go versus a plane. We have lots of different equipment that we use to observe whales. So one really cool piece of technology is called a hydrophone, which is an underwater microphone. So different species of whales produce different characteristic sounds. So you can often distinguish between a humpback whale, a fin whale, and a right whale. And so we'll listen passively for these whales as they come in and out of their habitats, although they're not always making these sounds, which makes it tough. We use cameras and binoculars, again, to take photos of the whales, look at their body condition, try to photo identify them. They also can put tags on whales. So they'll attach often via suction cups, and they have a little antenna here that will transmit information about how deeply they're diving, the temperature of the water that they're in. They can also sometimes have hydrophones to listen to the sounds the whales make, and also often will transmit a GPS location. Although I have an asterisk here because it is very difficult to tag North Atlantic right whales with these suction cups. They seem to be very slippery. They don't have a dorsal fin to like easily attach a tag to, and they like to rub up on each other. So they'll often just knock it off. So we don't have very long-term deployments of these tags from North Atlantic right whales. All right, and another platform that's recently been developed is a drone. Now, what is a drone? It is a remotely piloted or unoccupied aircraft system. And these drones have been designed now to carry various sensors that can collect a range of data without someone, you know, having to get in a plane and get overhead these whales. There are 2 main types of drones. One is a multi-rotor, which has multiple propellers. So we have a quadcopter here, hexacopter with 6 propellers here. And the other common one is a fixed wing drone, which resembles an airplane. And it can often be pre-programmed to run certain tracks in the air and survey for animals. Now, you might be more familiar with drones in the urban environment. They've been developed to put out fires, to save drowning victims, to deliver your packages probably soon, or to inspect hard to reach infrastructure. So if you're really interested in drones and technology, I highly suggest you follow the hashtag drones for good on social media, and you'll get some of these cool updates about what drones are being used for. And so in the biology environment, drone research is really taking off. So what's really cool about drones is that they provide this unique sampling perspective. So they get above the what we're trying to study versus someone on land. They provide higher resolution than you can get from a plane or even higher up a satellite. They're safer than occupied aircraft because it doesn't require putting people in the air. They're less invasive than approaching animals by a boat. They make less noise and they're smaller. And they're becoming increasingly accessible, affordable, and reliable. So the technology is constantly improving, making it a lot more user-friendly to incorporate these drones into research programs. So just to show an example of how drone imagery gives you a huge advantage over a boat-based photo, this is a tail of a North Atlantic right whale from a drone, from a boat. The drone allows us to see these entanglement scars on the whale, which could actually help photo identify an individual. Whereas from a boat, depending on the resolution, the lighting, the sea state, you don't get that same detail. So these drones are allowing us to collect much more detailed data. So at the University of New Brunswick in Saint John, I'm conducting drone research with our lab's drone, which we affectionately call Maddie because she is a DJI Matrice 210V2. And Maddie is specially designed to carry two sensors. She has a visible spectrum or RGB camera that also can record precise altitude of the drone during the flight. And then she also has a thermal imaging camera, and that allows us to get temperatures of the animals or anything that's out of the water. So for my research, we've been flying the drone in the Bay of Fundy and the Gulf of St. Lawrence the past 2 summers. We've conducted 78 flights over right whales, as well as humpback whales and fin whales. And you can see here, this is me flying the drone from our research vessel. Here's the whales blow. And if anyone was listening earlier, this is a humpback whale, so a bushy blow. And then the drone is hovering above. And I'm going to show you a little clip of what it looks like to launch the drone from the boat. We use a lot of safety gear because those propellers can take off limbs. So a lot of helmets and gloves and cut resistant sleeves. But here's a video of us launching our drone from the boat. All right, so that's what it looks like. You probably heard, hopefully you heard me like yelling at the top of my lungs, launching. It's a very noisy environment. The drone can, the propellers rotating produce a good amount of noise. So that's what it kind of looks like when it all works well. And then this is what the drone sees when we are over a whale. This is a humpback whale. I've sped up the parts in between the surfacings of the whale, but we have the visible spectrum or RGB imagery on the left and the thermal imagery on the right. And so I'm going to play that again. What I want you to pick up is that when the whale surfaces to breathe, its blowholes appear white. And that's white on the spectrum. It means hot. So you'll notice as it comes up to breathe, blowholes open, white, hot. And the rest of the whale is pretty much the temperature of the water. You can see the tail come out there. So what are we using these drone data for? There are many goals, and I'm sure there are going to be many uses that I haven't even thought of. But the first for my research is photogrammetry. And photogrammetry is the deriving measurements from photos if you know the camera's focal length and how high it is or how far away it is from an object. And so using the, you can scale the pixels based on those measurements. So we can measure the length of the whale, the width of the whale, and use this as a proxy for body conditions. So a skinny whale will have a higher length to width ratio than a fatter whale of the same size. So we can use this as an estimate of health or body condition. The thermal imagery we can use to measure those blowhole temperatures as an estimate of internal body temperature. So it's almost like using a contactless thermometer these days with COVID, you know, you point it at your forehead, except with whales, they're so well insulated that pointing it at anything external, it's not going to give you an accurate temperature. So you have to kind of like look inside the blowholes or look inside the whale to try to get a more accurate internal body temperature. So again, highlighting how hot those blowholes are here. And one of my main thesis questions is, do blowhole temperatures correspond with body condition? So if you have a skinny or a compromised whale, do they have a different body temperature than a robust or healthy whale? In other words, do whales get fevers when they're sick? Or are skinny whales colder because they have less blubber, they've metabolized all that fat and therefore are less insulated? So these are questions, you know, we can't just stick a thermometer in a whale's mouth and we can't catch a whale because of the stress and how large they are. So this is our best way of getting these really detailed health metrics. The other cool thing that we're contributing to with the drone imagery is this new Smart Whales initiative that's been started by the Canada Space Agency, where they're trying to use satellite imagery of the open ocean to automatically detect whales. So you can see there have been some preliminary studies. So these are satellite images. They're only getting higher and higher resolution. It's crazy. But you can actually start to identify different features of whales. And we're hoping to develop an algorithm that can process through the millions of photos that satellites get a day and say, hey, here's a North Atlantic right whale. And that can help us research them and protect them. And so the premise with the drone work is that if we get a high enough altitude photo of a right whale, so this was taken with the drone at 90 meters, we can pixelate or downgrade the photo to something we would see with the satellite and train the algorithm to say, hey, this is a right whale versus, hey, this is all water, this is not a right whale. All right, so I've kind of talked about how we're studying the whales, but I also want to get into how we're studying their prey. Also, studying the prey comes with challenges too. For example, the copepods that right whales feed on, they live at depth. They're very small. So this is my advisor, Dr. Kim Davies here. She's got on her thumb a tiny krill, which is actually typically larger than a copepod. So they're very hard to observe. You can't just like jump in the water and look for them or use any of these other observation platforms that we have for whales, much larger. So in the Davies lab at the University of New Brunswick, we have several pieces of oceanographic equipment that we will deploy off the back of our research vessel. So for example, we will tow nets underwater to collect plankton. And this allows us to identify the species, to estimate abundances. And then we also have a cage with a bunch of underwater sensors. So here is the cage. This is called a ring net here. You can see someone filtering the sample out of the ring net. But the cage here has a bunch of sensors. It can measure the salinity of the water, the temperature and the depth. It has an echo sounder, which uses sonar to estimate the abundance of particles in the water. So basically sends sound out and measures the backscatter to estimate abundance of plankton. There's also what's called an optical plankton counter, which is kind of this funnel that is profiling the water vertically. And there's a laser beam in the tunnel there. And every time a particle interrupts the laser, it counts it and can also estimate the size of the particle. So again, we can estimate abundance. It's kind of scanning the water column for these copepods. The other cool piece of equipment that our lab uses is an oceanographic glider. And so these are kind of like underwater drones. No one sits inside them, but they're pre-programmed to sample very broad ranges. They can go out for months at a time. For example, a glider was deployed last year in the Gulf of St. Lawrence, actually two, And so you can see kind of the profiles they took, and each dot here is a whale detection. They have a hydrophone on board so they can listen for the whales. And they also they can collect, they have an echo sounder as well as temperature, salinity, depth. And here's just a picture of it being deployed off the back of our vessel here. It's kind of sped up and then slowed down. Okay. And then it'll start going on its way, profiling the water. And that just allows us to sample the habitat on a much broader scale than we would be able to accomplish just pinpointing with our boat and sampling with a net. So some of the overall goals of sampling the whale's prey are to compare the plankton data to whale presence and environmental variables. This will allow us to predict where the whales will be, right? The whales have to be where their food is. And in that way, we can help protect them from shipping and entanglements in fishing gear. We can also start to evaluate whether prey quantity and quality is limited. Like I said, in the Gulf of St. Lawrence, we still don't know how much prey there is, whether it can support these North Atlantic right whales after climate change has really altered their historical feeding habitats. So ultimately, our goal is to reduce the anthropogenic or human impacts in these important feeding habitats. And I have some exciting preliminary data to show you, just to emphasize how this information can be used for conservation. So in 2019, in the Gulf of St. Lawrence, we deployed our cage. The bottom depth was about 90 meters, but in order to avoid damaging our equipment, we only deployed it to 80 meters. And on the x-axis is the abundance of copepod-sized particles from that optical plankton counter. And again, y-axis is depth, so going down deep. Now, we looked at the abundances that we were getting, and they were in the hundreds. But previous studies have shown that right whales really need abundances in the thousands to support their daily energetic needs, which led us to think, is prey limited in the Gulf of St. Lawrence for these whales? Will they be able to find enough food? However, just this past summer, we accidentally hit the sea floor with our cage. Now, nothing got damaged, fortunately, but it could have been worse. But what we found was really surprising was that right in those bottom 10 to 15 meters, we were starting to see the abundances of copepod-sized particles that these whales need, so in the thousands. Now, what this is very important for conservationists and policymakers to know, because if the prey is concentrated at the very bottom and the whales are feeding there, there's higher risk of these whales getting entangled in gear that's deployed along the sea floor for fishing industries. So very important information for us to know about these whales and their prey. All right, so I've kind of gotten into the research because that's what I know best, but I also want to talk about rescue operations. So inherently, so a rescue operation is where people, highly trained people, will go out, try to disentangle a whale or intervene when the whale is injured or sick. And this obviously has an inherent risk to both the whales and the people. These whales are very strong. They have big tails. They can move very fast. And in order to disentangle a whale, you have to get pretty close sometimes. And so that's why we need highly trained individuals to go out and do these sorts of things. So I'm actually gonna, I don't know if I'm allowed to do this, but if you all have your phones on you, I'm actually going to encourage you to take your phones out, not to check your messages, but to plug this number into your phone. So it's a great number to have in case you ever see a whale that's in distress. Say, like, it's better than having to Google it later on. If you are ever concerned about a whale, you see a dead one, you think it's entangled, you can call and report the whale to this number. In Atlantic Canada, there are several organizations that will respond to injured or entangled whales. That's the Campobello Whale Rescue Team, Whale Release and Strandings in Newfoundland, and the Marine Animal Response Society. What I have to emphasize, though, is that not every rescue operation is successful. So there are variable outcomes. And sometimes these whales are just so severely entangled, it prevents them from feeding. They can't swim. Sometimes they're anchored to the bottom and it prevents them from surfacing to breathe and they drown. It's just really awful, horrendous ways these whales die because of being entangled in fishing gear. However, I do have like a tragically inspiring story of one whale nicknamed Snow Cone. So Snow Cone is a 17-year-old adult female North Atlantic right whale. She got her name because her callosity pattern right up here looks like a snow cone. I think that's pretty accurate. And so Snow Cone was observed in December 2019 down in the southern US with her first calf, and it was very exciting. Everyone, so whenever a calf is born, you know, there may be a dozen a year. It's a big event. Sadly, however, that following spring, the calf was found dead. It had been struck by a vessel. Snow Cone then, about a year later, was seen entangled, and rescue operations took place. They tried to disentangle her. They were only able to remove some of the trailing line that at least made it easier for her to feed and to travel. And in fact, just this past December, this is what Snow Cone looks like now. This is her trailing line that she carries. They're still trying to find ways to possibly remove that gear, but she just gave birth to another calf this past December. So it just is a story about how resilient these whales can be. And if we give them a chance, a fighting chance, if we reduce our impacts on these whales, they can recover. All right, so what is the government? What are managers doing to regulate some of those human impacts, including vessel traffic and fishing? So my advisor and a colleague of hers wrote a paper, if you're really interested in this work, about how the Canadian government has kind of been spurred to action given the mortalities of these whales in our backyard. And so Fisheries and Oceans Canada, or DFO, has been regulating fishing, and Transport Canada is responsible for regulating the shipping. So DFO has come up with this strategy. They've divided the Gulf of St. Lawrence into a bunch of individual grids. And then we have a lot of researchers and platforms going out when the whales are here in the summer months, looking for whales, as well as listening for whales using hydrophones, gliders, you name it. They're using drones, they're using plane surveys, boat surveys. And so if a right whale is detected in one of these grids, it closes the grid to fishing. So the fishermen have to remove all their gear from that grid, as well as the 8 grids around it. Then those grids are then closed for 15 days. So it's about a 2,000 kilometer squared area closed for 15 days. If another detection is made in that same area during days 9 to 15 of the closure, that area is completely closed to fishing for the season. So no fixed gear can be laid, no fishing in that area to prevent entangling the whales. So this is these are some maps from 2021 showing how this actually played out. So in May, some of the whales will start to migrate into the Gulf of St. Lawrence through the Cabot Strait. You can see they started to detect some whales. There were already some closures in early May due to multiple detections off the Magdalene Islands. Then by July, the whales tend to come to the southwestern Gulf of St. Lawrence. So you can see lots of detections. This whole area was closed by July, and some temporary closures in other areas off Anacostia. And by October, you can see even more of the Gulf of St. Lawrence was closed to fishing, although by then most of the fishing is done in that area. So just to show a schematic of how whales can get entangled in this gear, usually there's a trap that's on the bottom connected to other traps through the ground line. Again, why if their prey are down there, they can easily interact with this gear. But then there's often a vertical line in the water that extends all the way up to the surface and has a buoy so that the fishermen can recover their gear and they know where it is. And what happens is the right whale will swim into that gear. Often they will they'll hit it, get surprised, and their first reaction is to roll and twist, and it'll get entangled around their flippers. It'll get wrapped up in their mouth if they had their mouths open, and around their tails. However, what I think is going to be one of the biggest technological advances to save these whales is the implementation of ropeless fishing gear. So essentially removing that vertical line from the water column and replacing it with an on-call buoy that then the fisherman can ping from their phone, and the buoy will inflate in that instant, and then they can recover it. And so this would essentially remove the possibility of whale getting entangled in the mid-water column, although might still pose an issue if they're feeding very close to the bottom. As I mentioned, Transport Canada has been implementing some shipping regulations. So this is a schematic of those regulations. So the pink area here is a fixed speed restriction for the months that right whales are typically in the Gulf of St. Lawrence. Same with this kind of darker pink area, just different months. The green here are temporary slowdowns when whales are detected in those areas. So our lab will often deploy a glider that will profile these areas. And there are also drones that will be programmed, those fixed wing drones, to fly over those areas. If they detect a whale, a ship has to reduce its speed when it's in this channel. In addition, there's a restricted area. Again, you saw where all those fishery closures were. The right whales really like this area to feed, it seems. This is where we do a lot of our research. It's called the Shediac Valley. And so vessels over 13 meters are restricted from this area unless you have a permit to do research in that area. And then just this past year, they implemented a voluntary slowdown along the Cabot Strait for ships. Now, a lot of times weather prevents these ship operators from satisfying the regulations, and of course human safety is important too. So this was voluntary. They're looking at compliance rates to see whether they can implement this as a enforceable slowdown area. All right, so I'm going to now touch upon outreach and education and how important that is to help protect these animals. So in my opinion, I think science communication is very important. You have scientists doing a lot of technical things, but if you're not translating that into action or into awareness, nothing's going to happen for these animals. So I like these opportunities to educate people. I hope that you take this opportunity to educate your families, your friends. Just telling them to go check out a link is better than nothing. I also, our research team this past year in the Gulf of St. Lawrence had a film crew aboard, and they were shooting a documentary called Last of the Right Whales, which is actually premiering in Moncton and Saint John in late February, and I'll actually be at the Q&A panel in Moncton on the 20th. So go buy a ticket to help support the right whales. You'll learn a lot more about the research and see us live in action. So that was a pretty cool thing to be a part of. If you'd like to learn more about what we're doing, these are some great links. So I can also send these to your teachers so they can share them with you, so you don't have to write them down now. But our lab has a lab website, so you can learn about the different projects that are happening, right in Saint John. The North Atlantic Right Whale Consortium is a group. It's pretty much anyone who's doing research on right whales is part of this consortium, and they put together a quarterly newsletter that they'll email out. So if you want to receive news about what's happening with the right whales, I suggest that you visit this link and sign up for the newsletter. You can also check out Whale Map. which is where all researchers will report sightings of not just right whales, but all large whales in Canada and now the US. So you can go and visit and see where whales have been within the past. It's like a 24-hour lag. So you'll be able to see where whales were yesterday. You can also help out. So again, I said, pull out your phones. Feel free to put these couple numbers in as well. If you are out on the water and you do see a whale, do keep your distance. You have to legally maintain at least 100 meters away from most whales, 200 meters if they have a calf or seem to be resting. So make sure you know those rules if you're out on the water. The Marine Animal Response Society also responds to any marine mammals, whether they're found alive or dead, injured, entangled, orphaned, sick. So that's another good number to plug into your phone in case you often walk along the beach. They also look for volunteers if you're looking for a way to get involved. You can support some of their response efforts. As I mentioned, DFO wants to know when North Atlantic right whales are seen. So if you ever see a V-shaped blow, or you see a whale come out of the surface with no dorsal fin, feel free to give them an email or a call, because even if you're not sure, that information is very important for us to know and protect these animals. And then if you've got some spare cash, the Canadian Whale Institute, as I mentioned, they're the home of the Campobello Whale Rescue Team. They're a great organization. They're the people going out, doing the rescues, doing the research, great organization to support. And so I wanted to also conclude with just some advice if any of you are interested in becoming a marine biologist. And I think there's a stigma about being a marine biologist. For example, I did a quick Google image search for marine biologist, and like all of them were scuba diving, all of them were like in tropical environments. And that's certainly not the case for the vast majority of jobs in marine biology. For example, there are various sectors you can get involved with in academia. So if you really like school, like I do, I'm a nerd like that, you can conduct research for these animals, you can teach. There are nonprofit organizations that will promote animal welfare. They'll also do research. They'll write grants to raise money and get involved with activism for these animals. Various aquaria throughout the world, they have animal care specialists that also get involved with research. Basically, any of these you can get involved with research. And in the government, like I said, they are often involved in translating that science that's being done to action. So if you like interpreting and solving problems, that might be a really good avenue for you to be a marine biologist. And so it's just some useful skills and recommendations. There's a lot of creativity involved, critical thinking, teamwork. I did a lot of sports as in my past, and so the things I learned there have been really helpful for me working in teams in the field. Good to take sciences, and not just biology, but physics, chemistry, earth sciences, all of them. Math, especially statistics. Computer programming is a plus, and writing and reading is also, and communication skills is very important, as well as time management. I will say there are some drawbacks to being a marine biologist. It's not just all like playing with whales and seeing them in the field and then, coming home at night. You have very long and unpredictable hours. Sometimes you have to travel, which can be a plus, but also takes you away from family and friends sometimes. And sometimes the field conditions are really hot, really cold, smelly, lots of flies, you name it. There's some weird field situation you'll be in. And I will say, like, the pay is sometimes on the lower side, but I think that that's outweighed by the reward you get from helping these animals and that you're helping the planet. That at night helps me sleep and makes me feel like I'm really making a contribution. So with that, I'd like to give a special thank you to all of you, first for attending, the teachers who helped organize this, Saint John Naturalists Club, UNB, the Davies Lab that I'm a part of, as well as at Dalhousie, the Taggart Lab is our colleagues of ours, ACAP Saint John and Eastern Charlotte Waterways have supported a lot of my drone research, as well as Irving Nature Park, Rockwood Park, and the town of Hampton. They give me permission to fly our drone. Also, the Saint John Model Flying Club has taught me a lot of what I know. And of course, I need to thank the oceans, because without them, we wouldn't be anywhere. I would be a marine biologist. And I will mention that all the drone imagery that you saw in this presentation were taken under necessary permits and authorizations. And while drones are becoming very accessible to anyone, you do need to follow. There are a lot of rules. And if you're interested, I suggest you do some research and homework on how to use them. And with that, I've put up my email in case any of you have specific questions or want to talk to me one-on-one. You can also follow me on social media. My username is Gina, Eubelina being the genus name of right whales. And I also have a personal website if you feel like checking out some more imagery. So thank you for your time, and hopefully we have time for questions. Get some drink.
Thank you so much, Gina, for that amazing presentation. So if anyone has questions, I know I'm going to unmute the Harbourview High feed.
We're just going to be like relaying the questions because you can't hear them that well.
Okay.
Do we have any local toothhead whales?
What whales? Sorry.
Toothhead whales?
Toothhead? Do you mean beaked whales? I'm not familiar with a toothhead whale.
So it's like the two different type of whales. There's the baleen and then there's the...
Oh, yeah, right. Okay, yes, I get what you're saying. So yes, we have baleen whales and then toothed whales. So toothed whales are called odontocetes, is their formal name. And that includes dolphins. Dolphins are actually considered under the umbrella of whales. Sperm whales would be the other toothed whales. I wouldn't say they're in the Bay of Fundy. They're a deeper diving species, so off the continental shelf. You will get pilot whales, which are actually in the dolphin family, but are called pilot whales, so they have teeth. I'm trying to think. Well, beluga whales are farther north in the Gulf, not in the Bay of Fundy, but in the Gulf of St. Lawrence. What other species might be? And beaked whales. So beaked whales are actually these really cool species that will hold their breath for like an hour and a half, and they dive to like 3,000 meters. And so they'll sometimes find their way locally, but again, usually farther off the shelf. So yeah, great question. Yeah, there are toothed whales and baleen whales.
Are there any
Are
species?
there any species of whales that have gone extinct? Is the question.
Any whales that
have gone extinct.
that have gone extinct.
Are there any whale species that are extinct?
Yeah, so the North Atlantic right whale would probably be the largest whale that will have gone extinct very well in our lifetime if it does go extinct. But there have been a few dolphins that have gone extinct within the past couple decades. So the Yangtze River dolphin is mostly endemic to China. They're like functionally extinct. There might be like one or two of them left. And then there's also the vaquita, which is a small porpoise that's found in Baja, Mexico. And because of the gillnet fishery, I think there are like the maximum left is 22, and there might be as few as 9. So that's probably the next closest one to extinction. But there was also the stellar sea cow, which not a whale, but related to manatees, that back when Europeans discovered them, I forget which century it was, like the 1700s, they went extinct within 100 years because of hunting. So there's a string of species that have gone extinct because of us, although through history, like all the way back over the evolutionary scale, certainly species of whales have come and gone with natural selection.
How do whales see their prey?
How do whales see their prey?
Yeah, that is a great question, and one I often ask myself. So whales don't have great eyesight. Their eyes are pretty small. We're still trying to figure out how they actually figure out where their prey is. In the case of humpbacks, you might recall I mentioned those tubercles, those little bumps on their face, and you can actually see some of the lumps, not the white things, those are barnacles, but the lumps on this humpback whale. They have little sensory hairs that come out of those tubercles. North Atlantic right whales also have sensory hairs on the tip of their heads that we think can sense when little particles are in the water. And so it'll trigger them and go, oh, there's stuff around, and they open their mouths. But we're also, I'm going to be involved with some research this spring where their plankton have this compound called dimethyl sulfide that they emit, and we're not sure whether whales can smell it or taste it in the water when they open their mouths, but we're going to be kind of experimenting with that compound and looking at how whales respond to that compound in the wild. So yeah, really great question. Toothed whales will use echolocation to find their prey, so they use sound. And we don't believe that happens in baleen whales. They're not built the same way. So yeah, still scratching our heads on that.
Whale watching is something I think is pretty popular. Is that something that distresses the whales, or do they notice?
Did you hear that?
So whale watching and whether it disturbs the whales, is that what it was?
Yeah.
Does whale watching disturb the whales, or is it?
Right. So there are mixed feelings with whale watching. If you have a company that's responsible and keeps their distance and is respectful of the whales, it minimizes the impacts. Have I seen whale watch companies race towards whales, get a little closer than they should? Yes. So I think when done responsibly, it can be a great way to get people excited about the animals, want to help them and get to see these animals closer. But we have to be responsible about the impacts on these animals and how many boats are around them, how often they're exposed to these sounds. I mean, I didn't get into the impacts of underwater noise, but with all the shipping industry, all the fracking and coastal development, the noise pollution in the ocean is increasing for lots of species, and that can have impacts on how these animals communicate with each other. In the case of toothed whales, how they find their prey through echolocation. So yes, it's when done responsibly, I think it's a great educational tool, but the privilege can be abused, sadly.
All right. Thank you so much, Dr. Lonati. I hope you can hear me.
Yes.
I want to talk to all the great nice. Al, thank you for your attention and your excellent questions. It's very important now that you report directly to your period 3 class, so your teacher is present. So go directly to period 3. If you are a member of the Climate Action Club, however, just move up to the front and stay here.
Thank you very much.
Thank you very much.